The water cycle is the continuous movement of water on, above, and below Earth's surface. This cycle is essential for maintaining life on our planet, as it distributes water to various ecosystems and helps regulate the climate. Water moves through different stages, including evaporation, condensation, precipitation, and collection, creating a dynamic and ever-changing system. It is powered by the sun's energy. The sun acts as the driving force behind the water cycle, providing the necessary heat to initiate the process of evaporation. Without the sun's energy, the water cycle would come to a halt, and life as we know it would be drastically different. The journey begins with evaporation. This is the first step in the water cycle, where water from various sources on Earth's surface transforms into water vapor and rises into the atmosphere.
Evaporation is the process of water changing from a liquid to a gas, or water vapor. This transformation occurs when water molecules gain enough energy to break free from the liquid state and enter the gaseous state. When the sun heats up water in lakes, rivers, and oceans, the water molecules gain energy and start moving faster. This increase in energy causes the molecules to vibrate more vigorously, making it easier for them to escape into the air. As they move faster, they bump into each other more often. These collisions transfer energy between molecules, further increasing their chances of escaping into the atmosphere. Eventually, some of the water molecules have enough energy to break free from the liquid and escape into the air as water vapor, an invisible gas. This process is crucial for the continuation of the water cycle, as it allows water to move from the surface to the atmosphere.
Have you ever noticed that puddles dry up after it rains? That's evaporation at work. Even small amounts of water, like those found in puddles, can evaporate when exposed to the sun's heat. The sun's heat causes the water in the puddles to evaporate into the air. This process can happen quickly on a hot day, as the increased temperature provides more energy for the water molecules to escape. Warm air can hold more water vapor than cold air. This is because warmer temperatures increase the capacity of air to contain moisture, allowing more water vapor to be present in the atmosphere. That's why clothes dry faster on a warm, sunny day than on a cold, cloudy day. The heat from the sun and the warm air work together to speed up the evaporation process, making it easier for water to leave the fabric and enter the air. Evaporation is like a magic trick. It seems to make water disappear right before our eyes, but in reality, the water is simply changing form and moving to a different part of the environment. It makes water disappear from sight, but it doesn't actually go away. The water vapor that forms during evaporation rises into the atmosphere, where it can eventually condense and fall back to Earth as precipitation. It simply changes form and rises into the atmosphere. This transformation is a key part of the water cycle, ensuring that water is continuously recycled and made available for all living organisms on Earth. The journey of evaporation is just the beginning of a complex and fascinating process that sustains life on our planet.
As water vapor rises higher into the atmosphere, it cools down. This journey begins at the Earth's surface, where water from oceans, rivers, and lakes evaporates due to the heat from the sun. The water vapor, being lighter than air, starts to ascend into the sky. This is because the air gets colder the higher you go. The temperature drops at an average rate of about 6.5 degrees Celsius per kilometer of altitude. This cooling effect is crucial for the next steps in the formation of clouds. As the water vapor cools, it loses energy and slows down. The molecules, which were once moving rapidly, begin to move more sluggishly. This reduction in energy is a key factor in the process of condensation.
Condensation is the opposite of evaporation. While evaporation involves the transformation of liquid water into water vapor, condensation is the reverse process. It is the process of water vapor changing back into liquid water. This transformation occurs when the water vapor cools sufficiently to reach its dew point, the temperature at which air becomes saturated with moisture.
When the cooled water vapor comes into contact with tiny dust particles in the air, it condenses or clings to them, forming tiny water droplets or ice crystals. These particles, known as condensation nuclei, provide a surface for the water vapor to condense upon. These tiny water droplets or ice crystals are so small and light that they can float in the air. They are often less than 20 micrometers in diameter, making them almost invisible to the naked eye. As more and more water vapor condenses, billions of these tiny droplets or ice crystals clump together, forming clouds. This aggregation of droplets or crystals is what gives clouds their visible form.
Clouds come in all shapes and sizes. They can be as small as a few meters across or stretch for hundreds of kilometers. Some clouds are puffy and white, resembling cotton balls floating in the sky. These are typically cumulus clouds, which form in fair weather conditions, while others are dark and grey. These clouds, such as nimbostratus or cumulonimbus, often indicate stormy weather and can bring rain, thunder, and lightning. The type of cloud that forms depends on the temperature and the amount of water vapor in the air. Warmer air can hold more water vapor, leading to the formation of larger and more complex cloud structures. Condensation is like turning a cloud into a glass of water. Imagine the countless tiny droplets coming together to form a single visible entity. It's the process of transforming invisible water vapor back into a visible form we can see and touch. This transformation is a fundamental part of the water cycle, which sustains life on Earth by distributing water across the planet. The water cycle includes evaporation, condensation, and precipitation, ensuring that water is continuously recycled and made available for all living organisms. When clouds become heavy with condensed water droplets, they eventually release this water in the form of precipitation, such as rain, snow, sleet, or hail. This precipitation replenishes water sources on the ground which plants and animals rely on for survival. The sun then heats these water bodies again, causing evaporation and continuing the cycle. This endless loop is vital for maintaining the balance of ecosystems around the world. As more and more water droplets or ice crystals collect in a cloud, the cloud gets heavier and heavier. This process is a fascinating dance of nature, where tiny particles of water vapor come together, driven by the forces of condensation and coalescence. Each droplet or crystal adds to the mass of the cloud, making it an ever-growing dynamic entity in the sky. Eventually, the cloud becomes so heavy that the air can no longer hold it up. The balance between the upward force of the air and the downward pull of gravity is disrupted. This tipping point is crucial in the formation of precipitation, as it signals the moment when the cloud can no longer sustain its load.
Precipitation is any form of water that falls from clouds to the Earth's surface. It is a vital component of the Earth's water cycle, replenishing our rivers, lakes, and oceans. Without precipitation, life as we know it would not be possible, as it provides the essential water needed for all living organisms to survive. The most common types of precipitation are rain, snow, sleet, and hail. Each type has its own unique formation process and characteristics. Rain, for instance, is liquid water droplets, while snow consists of ice crystals. Sleet is a mix of rain and snow, and hail is formed from layers of ice accumulating around a nucleus.
When the temperature in the cloud is above freezing, the water droplets in the cloud collide and combine to form larger drops. This process, known as coalescence, is driven by the natural tendency of water molecules to stick together. As these droplets merge, they grow in size and weight. When these drops become too heavy to stay suspended in the cloud, they fall to the ground as rain. The journey of a raindrop from the cloud to the ground can be influenced by various factors, including wind patterns and air temperature. This descent is a crucial part of the water cycle, returning water to the Earth's surface.
If the temperature in the cloud is below freezing, the water vapor freezes directly into ice crystals. This process, known as deposition, bypasses the liquid phase entirely. The formation of ice crystals is a delicate and intricate process, influenced by the temperature and humidity within the cloud. These ice crystals collide and stick together, forming snowflakes. Each snowflake is unique, with its own intricate pattern and structure. The process of snowflake formation is a beautiful example of nature's complexity and creativity. When the snowflakes become heavy enough, they fall to the ground as snow. The accumulation of snow on the ground can create stunning winter landscapes, transforming the environment into a white wonderland. Snow plays a crucial role in the Earth's climate system, reflecting sunlight and insulating the ground.
Sleet and hail form when rain falls through a layer of freezing air near the ground. This layer of cold air causes the raindrops to freeze into small pellets or larger balls of ice. The formation of sleet and hail is a testament to the complexity of atmospheric processes and the variability of weather conditions. Sleet is made up of small, icy pellets, while hail is made up of larger balls of ice. The size of hailstones can vary greatly, from small pea-sized pellets to large golf ball-sized chunks. The formation of hail involves strong updrafts within thunderstorms, which carry the ice pellets upward, allowing them to accumulate more layers of ice.
Precipitation is like the grand finale of the water cycle. It is the culmination of a series of processes that begin with the evaporation of water from the Earth's surface, followed by condensation in the atmosphere, and finally, the return of water to the ground. This cycle is essential for maintaining the balance of water on our planet. It's the moment when all that water vapor that has been traveling through the atmosphere returns to Earth's surface. This return is not just a simple fall of water. It is a vital process that sustains life, nourishes ecosystems, and shapes the environment. The water cycle is a continuous dynamic system that connects all living things and the natural world.
When precipitation reaches the Earth's surface, it can take many different paths. Some of it soaks into the ground and becomes groundwater, which can stay underground for hundreds or even thousands of years.
Some precipitation flows over the land as runoff, eventually making its way into streams, rivers, lakes, and oceans. Some of it evaporates back into the atmosphere, starting the cycle all over again.
This process of water collecting on the Earth's surface is called collection. Collection is an important part of the water cycle because it replenishes the Earth's water supply.
The water cycle is a continuous process, which means it never stops. Water is constantly moving between the Earth's surface, the atmosphere, and back again.
This continuous movement of water is essential for life on Earth. Imagine a giant invisible conveyor belt carrying water from the oceans to the clouds and back again. That's what the water cycle is like. It's a never-ending journey that ensures there is always water available for all living things.